No other polynomial of this form comes anywhere close. Why does this polynomial work so well? The discriminant of x squared plus x plus 41 is 1 minus 4 times 41, which is negative 163. There it is again, the same number. The reason this polynomial is such a prolific prime generator is directly connected to the fact that 163 is a Heegner number. Class number 1 means that the associated number field has a particularly clean algebraic structure, and that cleanliness translates into the polynomial producing primes far more often than it has any right to. The prime machine runs on 163. Now let's go back to Ramanujan's constant and trace why 163 makes it work. There is a function in mathematics called the J-invariant. It comes from the theory of elliptic curves and modular forms. You do not need to understand its full definition to appreciate what it does. The J-invariant takes a special complex number as input and returns another number as output. Its key property is this. When D is a Heegner number, the J-invariant evaluated at a specific point associated with D produces an exact integer, not approximately, exactly. This is a proven theorem. For D equals 163, the J-invariant at that point equals negative 640,320 cubed. That is a specific exact integer, a very large one, but an integer nonetheless. Now, the J-invariant also has a Fourier expansion, a series representation where each term involves a quantity called q, which for our purposes equals e to the negative pi root 163. The first term of the expansion is 1 over q, which is e to the pi root 163. That is exactly Ramanujan's constant. The remaining terms in the series are exponentially small, so e to the pi root 163 is almost exactly equal to an integer because the J-invariant forces it to be. But the number 640,320 is not finished surprising us. It appears again in the fastest known algorithm for computing the digits of pi. The Chudnovsky algorithm, published in 1989, computes 14 new digits of pi with every single term of its series. It is the formula behind every world record for pi computation since it was discovered. The central constant in the Chudnovsky formula is 640,320, and that constant comes directly from the J-invariant evaluated at 163. Let that sink in for a moment.